This is Euclid Book 10, proposition number 35. And look at this. We're going to do the exact same diagram as we did in the last video. Okay. Are we ready? To find two straight lines incommensurable in square, which make the sum of the squares on the medial and the rectangle contained by them medial, and moreover incommensurable with the sum of the squares on them. Let there be set out two medial straight lines, AB and BC. Okay, so this line is medial, and so is this. Okay. They are commensurable in square only. In other words, there is no number that's going to divide up those two lines, but if you made them into squares, there is a square area that will divide both those square areas. Okay. Containing a medial rectangle, and such as the square on AB is greater than the square on BC by the square on a straight line incommensurable with AB. This is by Euclid Book 10, proposition number 32, which we just did like 3 or 4 videos ago. Okay, let the semicircle ADB be described on AB. So what is the semicircle? Well, I think you recognize this. There's the semicircle. And let the rest of the construction be as above. So, we've just constructed all this. Okay. Then, since AF is incommensurable in length with FB, okay, so this line is not commensurable with this line. These two lines are, well, this line and this line are incommensurable. And this is by Euclid Book 10, proposition number 18. AD is also incommensurable in square with DB. Okay. This line here is incommensurable in square with this line right here. Alright, so that means if you make a square out of this and a square out of this, those two squares, their areas would be incommensurable. This is by Euclid Book 10, proposition number 11. And since the square on AB is medial, okay, so this square, if you're going to make this line into a square, that's got to be medial. Therefore, the sum of the squares on AD and DB are also medial. So this square and this square, if you add those areas together, because they're going to be equal to this square, they're going to be medial as well. Well, actually, these squares won't be, but their sum will be. Okay. And that's by Euclid Book 3, proposition number 31, and Euclid Book 1, proposition number 47. And since the rectangle AFFB is equal to the square on each of the straight lines BE and DF, okay, so we're going to form a rectangle. Two sides of the rectangle are going to be this length, and two sides are going to be this length. Alright? Now, that area is going to be equal to the straight lines BE and BF. Okay? That's because, well, here it is. BE, you're going to make a square out of BE, you're going to make a square out of DF, and that rectangle is going to have the same area as that and that. Okay? Therefore, BE is equal to DF. Alright? So, the length of BE is going to be the same as the length of DF. Okay. Therefore, BC is double of FD. So this line right here is twice as long as this one. So the rectangle ABBC, okay, in other words, we're going to make a rectangle out of this line right here and this line right here. Two sides are going to be this length, two sides are going to be this length. Therefore, the area inside that particular rectangle we just drew is double the rectangle of ABFD. So if we make a rectangle out of this and this, two sides being this long, two sides being this long, the area inside of that will be only half as much as the rectangle we just drew a couple of minutes ago. Okay. But the rectangle ABBC is medial. Okay. Therefore, the rectangle ABFD is also medial. Now, as you know, we just drew two rectangles. Both of them are medial. And this is by Euclid Book 10, proposition number 32, porism. And the rectangle ABFD is equal to ADDB. So, this rectangle, we drew these two lines and these two lines. We made a rectangle out of that. That is equal to, that area is equal to the area of ADDB. So we have AD and DB. And those two areas, not two areas. If we made a rectangle with two sides like this and two sides like this, the area inside that rectangle is equal to the area of AB and FD. Okay. And that is because the lemma after Book 10, proposition number 32. Therefore, the rectangle ADDB is also medial. And since AB is incommensurable in length with BC, okay, so this length is not commensurable with this length. And CB is commensurable with BE, so CB is commensurable with this. Therefore, AB is also incommensurable in length with BE. So this length is incommensurable with this length. And that's by Euclid Book 10, proposition number 13. So if the square on AB is also incommensurable with the rectangle ABBE. Okay? So the square on AB, we're going to make a square out of this line right here. And we're going to make a rectangle AB and BE. So two sides of the rectangle are going to be AB and two sides are going to be BE. So the area of this square is going to be the same as the area of that rectangle we just drew. I'm sorry. The square on AB is incommensurable with the rectangle ABBE which we just drew. And that's by Euclid Book 10, proposition number 11. But the squares on AD and DB are equal to the square on AB. So we've made squares out of this and this. If we add the areas of both of those squares, it's going to be equal to this. And this is by Euclid Book 1, proposition number 47. And the rectangle ABFD, well, here's ABFD. We're making a rectangle. Two sides will be this length, two sides will be this length. That is the rectangle ADDB. So, if we make a rectangle with this length and this length, it's going to have the same area as the rectangle with this length and this length. Okay? And those areas are going to be exactly the same. Now they're also going to be equal to the rectangle ABBE. So now we've made a rectangle, two sides this length and two sides this length. Okay? Therefore, the sum of the squares on AD and DB, we add these two together, is incommensurable with the rectangle ADDB. ADDB. So in other words, if we add the areas of these two squares and then we make a rectangle out of this side and this side, then the area of those two squares is going to be incommensurable with the rectangle we just made. Therefore, two straight lines AD, DB, incommensurable and square, have been found, which make the sum of the squares on them medial, and the rectangle contained by them medial, and moreover incommensurable with the sum of the squares on them. Wow, what a long proof. Alright, I will tell you more in my next video, so stay tuned.